Thanks very much. Okay, I'll just wait maybe 30 seconds for people to come in. All right. Okay, let's get started. So, hello everyone. My name is Mete Atamel. I'm a developer advocate at Google, and today I'm going to talk to you about WebAssembly, especially when it comes to running WebAssembly outside the browser. The presentation is already on speaker deck, and this is the link. And the demos I'm going to show, they're already on GitHub. And I'm going to share all these links at the end of the presentation. So if you want to get them, you'll have a chance at the end of the presentation with all the links. Also, before I start, at Google Cloud, there's this Google Cloud Innovators program where you can join and you'll get free credits, free learning, and communication from Google Cloud. So if you're interested, this is a QR code. And again, at the end of the presentation, there will be a link as well. Feel free to join if you want. All right. So what is WebAssembly and why we should care about it? So let's start with that, and then we'll get into WebAssembly outside the browser with some demos and things like this. What is WebAssembly? If you look at the definition from the webassembly.org, WebAssembly, also known as Wasm, it's a binary instruction format for a stack-based virtual machine. So it's a virtual machine, and it's also designed as a portable compilation target for programming languages. So basically, that means that you have your programming language that you're using, you can compile that to a Wasm module, and you run that in a virtual machine. Now, we are at the Java conference, and this might sound very much like Java, where you compile Java and run it in a virtual machine. So in that sense, it's kind of similar, but it's trying to do that in a more generic kind of way. So not just for Java ecosystem, but for any kind of programming language, really. An original use case for your WebAssembly was to augment JavaScript in the browser, because for better or worse, we are stuck with JavaScript in the browser. And for what you can do with JavaScript is limited, right? So if you want to run native code in a fast, portable, secure kind of way, that's when WebAssembly kind of makes sense, especially for games and 3D graphics for high performance kind of use cases. And all major browsers, Chrome, Firefox, and others, they support WebAssembly, and they've been supporting it for a while in the browser. And this is exactly why, for the longest time, I ignored WebAssembly totally, because I'm a backend developer, I'm a cloud developer, so WebAssembly didn't look like it was something relevant for me. Even for the front end that I work on once in a while, I do simple kind of front end. I don't need to do 3D graphics or games or anything like that. So WebAssembly really looked like something, maybe some other people deal with and not me. But then I started seeing some tweets. This is a tweet from Lynn Clark back in 2019, where she was talking about WebAssembly running outside the browser, and she was announcing this new project called WASI, which we'll talk about, where WASI enables running WebAssembly outside the browser. When I first saw that, I said, okay, that's interesting. But at the same time, everyone wants to run their code or their system everywhere, so what's the big deal? But then Solomon Hykes, which is one of the co-founders of Docker, he also made a statement on top, and he said basically that if Wasm and WASI existed in 2008, we wouldn't have needed to create Docker. Now at this point, I started thinking, because Docker has been the de facto standard for packaging and running services, especially in the cloud in the last 5-6 years. So if WebAssembly and WASI is relevant to that world, then maybe it's something that I should pay attention to as a cloud developer, right? And there was a survey from CNCF back in 2022, so last year, and one of the key findings of that survey was that containers are the new normal, and WebAssembly is the future. So again, this reinforces the idea that maybe WebAssembly is something that we should really start paying attention to outside the browser. So what does it mean, Wasm outside the browser? Well, there's been an attempt to run WebAssembly outside the browser using a project called WASI. And the idea here is that instead of running applications in virtual machines or containers, you can run them faster, smaller, more secure, more portable way using WebAssembly modules. This sounds great, right? Like, who doesn't want to run their code faster, smaller, more secure, and more portable way? But what do they actually mean? So it's faster because WebAssembly applications or WebAssembly modules, they start with no cold start. So typically, when you're running applications in a container, there's a little bit of lag when the container starts, and it all depends on what are you putting in the container. Even if you are using a serverless kind of service like Lambda or Google Cloud Functions, there's still a little bit of delay when the function first starts. Whereas WebAssembly modules, they try to get rid of that, basically. They try to load really fast, so fast that you don't really see that cold start. Smaller. So a WebAssembly module by default is really small. But even if you take a WebAssembly module and wrap into a container, and I'll talk about why you want to do that later, it's still much smaller than having a regular container. And there's actually this really good blog post from Nicholas that goes through compiling a Rust application into a container and compiling a Rust application to a Wasm module and into a container and comparing them. And he basically finds that the WebAssembly container is 3 to 20 times smaller. And maybe if we have time, we'll take a look at this blog post a little bit later. More secure. Sometimes we forget that containers, they execute in this allow by default policy, meaning most of the things are allowed in a container, and you need to kind of disallow them. You need to kind of harden your container. And this makes me really nervous because every time I am constructing my container, I'm always thinking, is this the most secure container I can have? Am I relying on a base image that's secure? I don't know. You have to be really expert in knowing that your container is really secure. Whereas in WebAssembly, the security policy is deny by default. So everything by default is denied, and you need to explicitly enable functionalities. And that enables you to have more secure modules by default. And more portable. Again, this is one of those things that we tend to forget. If you build a container for, say, Linux AMD 64 architecture, that container is not going to work on Linux ARM 64 architecture, even though they are both Linux, right? And forget about running the container on a Windows kind of architecture. Whereas if you compile your WebAssembly module to Wasm WASI module, which means a WebAssembly with WASI enabled, you can run the container, a module anywhere, basically. All you need is a Wasm runtime. So the portability story is much better on WebAssembly. So this all sounds really good, but does WebAssembly actually deliver on these premises? And the answer is yes in some ways and no in other ways, so we'll take a look at that as we go along. So now this kind of makes me think that, we came a long way from hardwares and VMs, and then we started having containers running on VMs. And now we're at this stage, we're at this stage where we have containers running, and then whatever is underneath, whether it's Kubernetes or Cloud Run Service or something like that, we don't necessarily care about it so much. We just care about the container and building the container and running the container. So maybe the next evolution is going to be this Wasm module. So take the same code, compile to a Wasm module, and run that without having to care about the underlying infrastructure in a smaller, more secure, faster kind of way. Is this the future? We'll see. All right, so before we get into details, one last thing I want to talk about is the use cases. So, when you're dealing with WebAssembly, what kind of use cases should you be thinking? And as I mentioned, the browser use case has been around for a long time. WebAssembly has been in the browser for a while. So if you need to run native code, high performance kind of code, 3D graphics, games, then at that point you should look into WebAssembly and see if you can do that with WebAssembly within the browser. Now the second area that's coming up is the plugins and edge kind of use cases. So if you need to run some kind of custom code in the edge, but you don't trust that code because maybe it's a custom kind of code, then maybe WebAssembly kind of makes sense in that case. For example, Shopify has something called Shopify Functions, where you can customize the Shopify checkout experience, and you can plug in your code as a function, and the function is in WebAssembly, and it makes sense to be a WebAssembly module because you can use whatever language you want, and it's also sandboxed by WebAssembly runtime, and so if the code is malicious or something like that, at least it's sandboxed. So those kind of use cases are coming up. Shopify is one example. Envoy, Proxy is another example where you can deploy a filter using a WebAssembly module. Fastly has something called Compute Edge. So we see this kind of use cases coming up. Another area is IoT. So IoT devices, they're very restrictive. But WebAssembly modules, they're very small, so they kind of go well together. And there's some WebAssembly runtimes that are geared for IoT kind of devices. And finally, the last area that's coming up is the cloud microservices kind of area. And there's a company called Fermyon, which is a startup that have a framework called Spin that's trying to give you a way to kind of write some code in their framework, Spin framework, and then deploy it to the cloud using WebAssembly. So if you go to this link from Fermyon, they get into these use cases and they explain them much more. But these are the 4 main areas I see as like the main use cases for WebAssembly. And I'm mostly interested in cloud microservices area because that's what I do. And the idea here is that we can run our services today, but we can run them maybe in a better way using WebAssembly in the future. So that's the question that we are trying to figure out. All right, so let's get into details now. So let's talk about Wasm runtimes and WASI. So as I mentioned, you normally have your source code. Normally, you compile to the architecture that you want to run that to. But with WebAssembly, you don't need to do that. You just compile it to a WebAssembly module, and that's it. You don't think about the architecture in that sense. So you just compile your code with WebAssembly. Now, once you have the code compiled anywhere, you can run it pretty much anywhere. So you can run it on different architectures. All you need is this Wasm runtime. So you need to have the Wasm runtime installed on the target architecture. But once you have that, this module can be compiled on Windows, for example, but you can run it on Linux without having to change it because of this runtime. Now, these runtimes, there's a lot of them. But the top 3 that I see is one, Wasm time. This is from Bytecode Alliance project, which is the body that's also behind the WASI project that I'm going to talk about. Another one is Wasm Edge from CNCF. Another one is Wasmer from a startup. And actually, if you go to this GitHub link, I won't go through this list, but I just want to show you that there's a lot of runtimes, right? And they all have their own flavors and their own specialties. So you need to kind of pick and choose depending on what you want to do with WebAssembly. But these 3 are the ones that I've seen, and I'm going to show you some in my demos later. So once you have your WebAssembly module running in the runtime, and now if you're outside the browser, you need a way to talk to the host. Let's say you want to write a file. The way you write your file on Linux is different than the way you run it on Windows. So you need this common interface to be able to do that in a common kind of way. And that's what WASI is about. WASI, it stands for WebAssembly System Interface. And it tries to give a common interface for WebAssembly modules to talk to different kinds of hosts. Now, WASI, it's a POSIX-inspired project, and right now it's in preview 1, so it's something in progress. And preview 2 is coming up at the end of this year, so pretty soon. And it gives you a very limited number of functions that you can call from your WebAssembly module to the host. For example, you can read and write files. You can read and write program arguments. You can read environment variables, things like this. But a lot of WASI is still in proposals. And there's actually a website you can go to and see all the proposals and their state. And they're quite limited. For example, there's no socket support yet in Wasm runtimes. So without sockets, you can't really do services, right? You can't read and write HTTP. So it's very limiting. Because of this, some runtimes implement their own sockets. For example, Wasm Edge, which is one of the runtimes, they have extensions for sockets for Rust, JavaScript, and C. So if you are using Rust, JavaScript, or C, and if you are running in Wasm Edge runtime, you might be able to do sockets and HTTP. But it's a very limited subset of WebAssembly. Some projects, they try to enhance WASI. One of them is called WAGI, which adds HTTP support around WebAssembly modules that we'll talk about. And another one is called WASIX, which tries to add full POSIX support around WASI, but it's only supported on Wasm runtime. And we'll also talk about this in a little bit. There's no garbage collection yet in WebAssembly, but there's a proposal. And I also heard an announcement from Chrome that they implemented garbage collection there. But the important point here is that if you want to run a garbage collected language like Java, then it becomes more complicated because of this, right? But it's something that's been worked on, and hopefully at some point there will be garbage collector. All right, so I want to show you quickly now how you take a piece of code and compile to a Wasm, WASI-enabled module and run it in a runtime. And how you do this depends on the language you're using. And I have this repository where I show you how to do this in Rust, .NET 8, Go, Kotlin. And as I play more, I will add more languages, but it really depends on the language right now. But just to give you a flavor, let's look at Rust, for example. So the way this would work, and I know it's probably difficult to see, but I will talk through it as much as I can. So first, you need to install your Rust environment, and then you need to install your Wasm runtime. So in this case, I'm installing Wasm time and Wasm Edge. Then in Rust, you add this target called Wasm32 WASI. So by adding this target, you are enabling Wasm, WebAssembly and WASI with Rust, right? So you do that by Rust target add Wasm32 WASI. And then you create your application. And in this application, again, you probably can't see it, but I'll explain. I'm basically saying hello world, and I create a file in /hello world folder with a hello world.txt. So I create a file, write something into the file, and then finish with that. So it's a hello world application, but the important point is that I'm writing something in the host, right? So I'm interacting with the host. And once we have this, you can compile that to a WebAssembly WASI module, and you do that by cargo build, and you pass the target Wasm32 WASI. So that target basically says, take this code and compile to a WebAssembly module with WASI enabled. So let's actually do this here. So now my code is being compiled, and then if I do a find Wasm, I have my Wasm module already compiled. And then to run it, we just pass this Wasm module to the runtime. But if you remember, I told you that everything in WebAssembly is disabled by default. So my module cannot talk to my file system yet. I need to enable that. And to do that, you pass this flag to your runtime, map directory. And then I say map directory /hello world, and then dot. What that means is that I'm saying /hello world in my Wasm module points to this directory on my host. So I'm enabling my host to talk to this directory, basically. So I can do that, and then run that with Wasm time, and then it says hello Wasm, and it created the hello world txt. So okay, that's great. And then if you want to use another kind of runtime, this time Wasm Edge, you can do the same thing again. The flag is different in Wasm Edge, but the same module runs in different runtimes on Mac, but I can also take the same module and run it on Windows, and it will still work, which is good. All right, so that gives you a little bit of intro to how you can do this kind of compilation. Of course, how you do this in Java or .NET or others is different, so you need to kind of play with it and see what happens. But I will keep updating my repo with different languages as I play with them. Okay, the next thing that you probably want to look into is running WASI in Docker. And at this point, you might be wondering, why run WebAssembly in a container? Because I kept telling you how WebAssembly is smaller, better, faster than a container. So why do you want to take that and put it inside a container, right? And I think the idea here is that, we are in this stage where we have the world containerized. We have Docker and Kubernetes, and we have container registries with Docker Hub, and we can push to these registries, we can pull from these registries, right? So the whole world is containerized today. But then we have this new world coming up with WebAssembly. There's no WebAssembly repositories yet, so that you can push and pull from these repositories. And if you want to run them, how do you run them? You need to have a way to run them, right? So that's why I think it still kind of makes sense to take this WebAssembly module, put it in a minimal container, and then all of a sudden, you can use this existing toolchain and existing world to run your WebAssembly modules. So that's why I think it kind of makes sense. But in the future, when WebAssembly is actually complete with its own ecosystem, I think we wouldn't need to wrap it into a container. So it's kind of like the middle ground until that happens. And there's this blog post I mentioned where one of the speakers I met at a conference, he was talking about how do you take a Rust application, compile to a WebAssembly module, put that in a container. So he did that, and then he took the same Rust application, created a standalone Rust container out of it, and then look at that container, and then he realized that the difference is that the WebAssembly module container was 2.6 megabytes, but the native one was 7 megabytes. And the reason is because the Wasm runtime is provided by the Docker desktop, so you don't need to have the runtime stuff within your container. Because of that, your container ends up being smaller. And then he went on, and then he added more stuff to this Hello World. He tried to add HTTP calls and added some frameworks. You can read more about this, but basically the point is that at the end of it, the WebAssembly container was 5 megabytes with all this extra stuff, whereas the Docker one was 123 megabytes, so much bigger. And again, the reason for this is that when you're building a container, you need to kind of figure out what you need as your base images. You need to figure out what you need to install into the container, and you need to make that as efficient as possible. And sometimes you add more things that you need, right? And then because of that, your container ends up being more than it needs to be. Whereas with WebAssembly, you just compile to a module, and the module is self-contained, and all you need is a runtime, but the runtime is provided by Docker, and with that, you end up having much smaller containers. So even in this case, it kind of makes sense to take your app, if you can, compile to a WebAssembly module and put that into your container, and it's still going to be much smaller. And then this is enabled by a project called WASI. WASI basically enables containerd to run WebAssembly modules. And starting in 4.15, Docker uses WASI to run WebAssembly modules. And Docker provides you 4 runtimes: Wasm Edge, Wasm Time, Spin, and Slide. So you cannot use any runtime. They chose this 4. Also in Azure, there's a service called AKS, Kubernetes service. They're also previewing WebAssembly node pools using WASI. And the way this works is that there's another great blog post out there that explains this. But basically, in today's world, we have Kubernetes using containerd to run runc, which manages containers, right? That's how it works today. But then what we are having right now is containerd not only managing containers, but they're also managing Wasm runtimes through this special shim. And in this shim, there is a WASI project, and there's also Wasm runtime that's there. And then with that, you can have WebAssembly modules running within Kubernetes as well, along with other containers, basically. So that's how that works under the covers. Now, how you take so the example that I showed you before, how do you take that and run it in Docker? It's actually quite easy. So let me just show you that quickly. So let's close this. All you need to do is, first you need to go to your Docker, and you need to go to Settings. And within Settings, there is this section called Features and Development. So you need to go there. You need to make sure that you have this containerd enabled, and you also need to enable this enable Wasm checkbox. So what that does is basically it enables containerd, and it also enables the Wasm runtimes that Docker has. So with that, you have your Docker ready for Wasm. Then you go to your application, you build your application, you create your module just like before. There's nothing special there. But then you create a Docker file. And the key thing about the Docker file that I want you to see is that the Docker file is depending on Scratch. Scratch means an empty container, basically. So it doesn't rely on anything. There's no base image. You don't need anything else because the WebAssembly module is self-contained. So you have that, and then you copy your WebAssembly module to your container, and then you just run that, and that's it. So So once you have that, you can go back to your console. You can do Docker build and just point to your Docker file, and this will, if my Docker works, this will try to build the container just like any other container, but it's actually has a WebAssembly module inside. Usually Docker stops working when I'm connected to conference Wi-Fi's, but let's see if it works. Yeah, I think I already have the image anyway, so let me Docker images. Let's see if that works. Yeah, the image is there, and then if you want to run this image, then you would just say Docker run, and then you need to pass in a runtime, and in the runtime, you basically point to a WebAssembly runtime. So in this case, I'm pointing to Wasm edge, and then point to my container, and then this will now run the container with the WebAssembly module inside. Let's wait for a few seconds if it's going to work, but I wouldn't be surprised because Docker seems to get out of sync when you connect to a new Wi-Fi, especially with the conference ones where you have to log in. All right, but what you would see is that basically this would run, and then it would run the WebAssembly module under the covers. I'll let that run and then continue with the presentation, and maybe we'll see it working. All right, so we have our WebAssembly module. We have our module wrapped into a container, but we still cannot do much with it, right? Because we don't have socket support, so we cannot read and write. We cannot do microservices, things like that. There are a couple of projects. The first one is called WAGI, WebAssembly Gateway Interface. And what it tries to do is that it tries to add HTTP around your WebAssembly modules. So the way this works is that in WAGI, you create a modules.toml file. And in this file, you map a path, an HTTP path, to a WebAssembly module. So here we will say path 1 goes to this module, path 2 goes to that module. And then when an HTTP request comes in, WAGI takes that request, then converts into a command line kind of request, and then your module reads that as a command line request, which is kind of weird. So you're not reading HTTP, you're reading command lines, but it's actually HTTP. And then to reply back, you write back to the command line. So it's kind of like CGI scripts, if you remember them, but for WebAssembly. And I will kill this. I will just show you this, how this looks like. So the modules.toml, you see I create my route, C#, and then it points to my .NET 8 WebAssembly module, and then I go to /go, and that points to my Go WebAssembly module. And I just want to show you the code just quickly. For example, if you look at the C# code, which should be quite similar to Java, it's just a console application, right? And when it receives a request, it will receive it through console. And when it replies, it will just write back to the console. So here, we're replying back with an HTTP status 200, and then we leave an empty line, and then we write the body after that. And the headers, HTTP headers, they come through environment variables. The HTTP query parameters, they come through command line options, although this doesn't work in .NET right now. So that's kind of the idea, and then you can just let WAGI basically do the HTTP and let your modules do the rest of the work that you need to do, okay? So that's how WAGI works. The other project that's coming up, it's called Wasix. So the idea of Wasix is, I think it's coming from the frustration from WASI, because the WASI project, it has been around since 2019, so it's been 4 years, and they have these proposals, but it's still missing a lot of things. Whereas Wasix, they basically tries to add all these missing POSIX features to WebAssembly. So they're trying to add networking, multi-threading, and all the rest, basically. But they're doing this in a non-standard kind of way. So it's not part of WASI standards. It only works on Wasm runtime, which is a runtime by a startup. And then the last time I tried Wasix, it was only working with Rust on a special version of Rust or something like that. So it's a very small subset of WebAssembly on a special language, on a special runtime where this might work. But we'll see how it will evolve, because I think this will push WASI to kind of iterate faster and kind of add all these missing features. And maybe this will become standard at some point, I don't know. But But you can see that people are getting to the point where they want to run WebAssembly, but they find that things are missing, and they're trying to push it forward through projects like WAGI or WASIX. Okay. All right. I show you the WAGI stuff, and I don't have that much time, so we'll skip this one. And in the last part, I want to talk to you about some frameworks and languages around WebAssembly. Well, first of all, there's a lot of WebAssembly frameworks out there, but if you are looking into running WebAssembly with microservices or cloud microservices, then I suggest you look into Spin. It's a framework by Fermyon, which is a startup, and it kind of is focused on microservices basically with WebAssembly. And it gives you a SDK, a Spin SDK, and it handles all the HTTP requests and responses for you. And they have SDKs available in Rust, Go, .NET, and other languages. So it's basically a good place to start from. And I won't run this, but I'll just show you. For example, if you want to run a Python application on Spin, it's quite easy to do. So once you have Spin installed, you install some special packages for your language. So in this case, you're going to install Py2 Wasm module, I guess, for Spin. And then Spin comes with a lot of templates. So in this case, you will say Spin new HTTP Py, which means it's a Python application with HTTP enabled. And that creates you a Python application. And if we look at that application, you will see that it's very similar to, let's see if I have it here. Yeah, this is the application. It's very similar to any kind of serverless function kind of application that you receive a request and you can reply back. But then to build it, you would just say Spin build, and to run it, Spin up. And under the covers, like Spin kind of basically figures out what you need to compile that application, and then what you need to run it, and what you need for HTTP to be enabled. And I think it uses WAGI, for example, under the covers, but you don't have to really care about it. The framework takes care of that for you, right? And then it would run, and then you would just be able to reach to it, and then it will be able to respond. So it's a WebAssembly module with HTTP around it provided by Spin, right? So it's a good place to kind of get started with microservices and WebAssembly. Okay, I kind of show you this. And in the very last part, I want to talk about language support for WebAssembly and WASI. Because people ask me, I'm using this language, then can I run it on WebAssembly in WASI on this platform, right? And the answer to that is quite complicated. It really depends. And actually, it's complicated also due to a lot of misinformation out there as well. So for example, if we look at Fermyon, which is a startup that I've been talking about, on their website, they have a list of languages and the WebAssembly support of that language in the browser, and the support in WASI for that language. So if you look at, for example, Java, it says, it's supported fully in the browser, and there's WASI support, so it kind of makes you think that, okay, Java is fully supported. If you look at Rust, which is also one of the fully supported languages on WebAssembly, it also has all these check marks. If you go to another website, this is another one, and it says, Rust has excellent support, C has excellent support, Golang has excellent support, which makes you think that, okay, I can run anything I want on WebAssembly, right? Well, it's not true, actually. For example, the excellent support in Rust means that you can take your Rust code and compile to WebAssembly quite easily. I show you how to do that. But you are living within the limitations of WASI, which means that there's no multi-threading, because multi-threading is not supported yet, which means that you cannot use a framework called Tokyo in Rust, which is the framework that most people use. So no Tokyo or async support in Rust. C and C++, excellent support, but you cannot use C++ exceptions, right? So without exceptions, it's going to be difficult. Go is excellent support, they say, but it's supported by a project called TinyGo, and TinyGo doesn't support reflection. So if you need reflection, it's not going to work. If you look at C#.NET, actually, Microsoft tries to do a good job of supporting WebAssembly. So there was some experimental support for .NET 7 in WASI SDK. but they totally changed it in .NET 8, which was just released last week. And then now they call it WASI experimental workload. So it's a totally different way of compiling your .NET application to WebAssembly, right? So they keep changing from version to version. Java, the good support that they were saying, it is supported, but it's only supported on something called TVM, which is a Java to JavaScript compiler, but it's only supported via a fork of that by Fermion. So Fermion forked TVM, and with that, Java is supposedly supported, although I couldn't get it working. I tried, and it was giving me some errors, and I just kind of gave up, okay? So the point here is that there is some language support. You can run some certain things, but it's very limited, and it's changing from version to version quite a bit, right? And because of that, I think the only way to know for sure if your code is going to work on WebAssembly and WASI is to actually compile it and run it and see that it works. Unfortunately, that's the state right now, but maybe it will change, and I see more and more progress every day on different languages. But right now, it's kind of a mess. All right, so conclusions. Wasm outside the browser, it's a very fast-changing landscape. Every time I look into it, there's something that changed, or something that used to work doesn't work, or something that didn't work now works. So we need to keep an eye on it. Standards and languages, they need to mature. So right now, it's not so easy to take your code and make it work. You need to really read a lot, or maybe make your language or your code a subset of what you need to do in order to get it working. So it's not there yet. They need to mature. Will it replace containers? I think it has the potential, right? So if we can end up with smaller, faster, more secure modules, it has the potential to replace containers, but it's not there yet. So we are still in this phase where it can go either way, I feel like, but it has a lot of potential as well. That's my feeling. Well, it's a good time to learn it, so that's what I try to do, and that's what I try to convey to you. So hopefully this was useful to you. If you want the slides, this is my speaker deck. If you want more examples, this is my repo. And I don't know if we have time for questions, but if we do, I'll be happy to take some questions. So thanks very much for listening.